An actuator is a component of a machine that is responsible for moving and controlling a mechanism or system, for example by opening a valve. In simple terms, it is a mover. An actuator requires a control signal and a source of energy. The control signal is relatively low energy and may be electric voltage or current, pneumatic or hydraulic fluid pressure, or even human power. Its main energy source may be an electric current, hydraulic pressure, or pneumatic pressure. When it receives a control signal, an actuator responds by converting the source's energy into mechanical motion. In the electric, hydraulic, and pneumatic sense, it is a form of automation or automatic control. An actuator is a mechanism by which a control system acts upon to perform an operation or task. The control system can be simple, software-based, a human, or any other input. Different type of actuator? Hydraulic actuators. The hydraulic actuator consists of cylinder or fluid motor that uses hydraulic power to facilitate mechanical operation. The mechanical motion gives an output in terms of linear, rotatory or oscillatory motion. As liquids are nearly impossible to compress, a hydraulic actuator can exert a large force. The drawback of this approach is its limited acceleration. The hydraulic cylinder consists of a hollow cylindrical tube along which a piston can slide. The term single-acting is used when the fluid pressure is applied to just one side of the piston. The piston can move in only one direction, a spring being frequently used to give the piston a return stroke. The term double-acting is used when pressure is applied on each side of the piston. Any difference in force between the two sides of the piston moves the piston to one side or the other. Pneumatic actuators. Pneumatic actuators enable considerable forces to be produced from relatively small pressure changes. Pneumatic energy is desirable for main engine controls because it can quickly respond in starting and stopping as the power source does not need to be stored in reserve for operation. Moreover, pneumatic actuators are cheaper and often more powerful than other actuators. These forces are often used with valves to move diaphragms to affect the flow of air through the valve. The advantage of pneumatic actuators consists exactly in the high level of force available in a relatively small volume. While the main drawback of the technology consists in the need for a compressed air network composed of several components such as compressors, reservoirs, filters, dryers, air treatment subsystems, valves, tubes, etc., which makes the technology energy inefficient with energy losses that can sum up to 95%. Electromechanical actuators. It converts the rotational force of an electric rotary motor into a linear movement to generate the requested linear movement through a mechanism, either a belt or a screw, either a ball or a lead screw, or planetary mechanics. The main advantages of electromechanical actuators are their relatively good level of accuracy respect to pneumatics, their possible long life cycle, and the little maintenance effort required might require grease. It is possible to reach relatively high force on the order of 100 kN. The main limitation of these actuators are the reachable speed, the important dimensions and weight they require. While the main application of such actuators is mainly seen in healthcare devices and factory automation. Electrohydraulic actuators. Another approach is an electrohydraulic actuator, where the electric motor remains the prime mover but provides torque to operate a hydraulic accumulator that is then used to transmit actuation force in much the same way that diesel engine hydraulics are typically used in heavy equipment. Electrical energy is used to actuate equipment such as multi-turn valves or electric-powered construction and excavation equipment. When used to control the flow of fluid through a valve, a brake is typically installed above the motor to prevent the fluid pressure from forcing open the valve. If no brake is installed, the actuator gets activated to reclose the valve, which is slowly forced open again. This sets up an oscillation and the motor and actuator will eventually become damaged. Thermal or magnetic actuators. Actuators which can be actuated by applying thermal or magnetic energy to a solid-state material have been used in commercial applications. Thermal actuators can be triggered by temperature or heating through the Joule effect and tend to be compact, lightweight, economical and with high power density. These actuators use shape memory materials such as shape memory alloys, SMAs, or magnetic shape memory alloys, MSMAs. Mechanical actuators. A mechanical actuator functions to execute movement by converting one kind of motion, such as rotary motion, into another kind, such as linear motion. An example is a rack and pinion. The operation of mechanical actuators is based on combinations of structural components, such as gears and rails or pulleys and chains. 3D printed soft actuators. The majority of the existing soft actuators are fabricated using multi-step low-yield processes such as micro-molding, solid freeform fabrication, and mask lithography. However, these methods require manual fabrication of devices, post-processing assembly, and lengthy iterations until maturity in the fabrication is achieved. To avoid the tedious and time-consuming aspects of the current fabrication processes, researchers are exploring an appropriate manufacturing approach for effective fabrication of soft actuators. Therefore, special soft systems that can be fabricated in a single step by rapid prototyping methods, such as 3D printing, are utilized to narrow the gap between the design and implementation of soft actuators, making the process faster, less expensive, and simpler. They also enable incorporation of all actuator components into a single structure, eliminating the need to use external joints, adhesives, and fasteners. Linear motor actuators. Linear motors are different from electromechanical actuators. They work with the same principle as electric rotary motors. In effect, it can be thought as a rotary motor which has been cut and unrolled. Thus, instead of producing a rotational movement, they produce a linear force along their length. Because linear motors cause lower friction losses than other devices, some linear motor products can last over 100 million cycles. Linear motors are divided in three basic categories: flat linear motor, classic, U-channel linear motors, and tubular linear motors. Linear motor technology is the best solution in the context of a low load, up to 30 kgs, because it provides the highest level of speed, control and accuracy. Which type of actuators need to create nano-robotic? That is, nano-robot actuation, piezoelectric actuators, piezotubes, thin film type, surface acoustic waves, electrostatic, thermal, ultrasonic, magnetostrictive actuators, shape memory alloy actuators, polymer actuators, dielectric elastomers, carbon nanotube, CNT, actuators, biomolecular motors.